Hello, good morning, students. We are already discussing problem number 18 from H.C.VARMA textbook. So that problem number 18 is like this. Test the following equations are dimensionally correct. Means whatever maybe the equations are given to us, so we have to check that correctness of that given equations. How we can check the correctness of given equations? So using dimensional analysis. So here question is clearly given to us, that is are dimensionally correct or not. What is the condition for dimensionally correction? So left hand side should be equal to right hand side. So in these equations we have already done one first problem. That problem is h is equal to 2s cos theta upon r rho rg. So this problem we already solved in our previous videos. Now we have to solve this second problem, that is v is equal to under root p upon rho. So to solve this problem we must know the parameters which are included in that formula. So the formula is given to us, that is v is equal to under root p upon rho. So let us we discuss the parameters which are given to us. So where v stands for what? Velocity. P stands for what? Pressure. Rho stands for density. So these are the parameters, okay, of this equation, that is v is equal to under root p upon rho, that is density. Now using dimensional analysis we have to put the dimensions of all these quantities. Now the quantities is velocity, then pressure, then density. So we must know the dimensions of these three physical quantities. So we have to put all the dimensions of this physical quantity in this relation. So let us we try to solve this problem. Here our equation must be LHS is exactly equal to RHS, that is left hand side should be equal to right hand side. So on left hand side velocity is there. So first of all we have to write the given equation, v is equal to under root p upon rho. So velocity, first of all calculate the dimensions of velocity. So velocity, the dimension of velocity is L1 t minus 1. We are familiar with this dimension, that is dimension of velocity is equal to dimension of velocity is equal to L1 t minus 1. Then this is on the left hand side, and on the right hand side density is there and pressure is there. So P stands for what? Pressure, and we know how to calculate the dimension of pressure. Pressure is equal to what? Force upon area. So we know the dimension of force, that is M1 L1 T minus 2 upon dimension of area, and that is L2. So M1 as it is, L2 it is plus, it becomes minus. So 1 minus 2, that is minus 1, L minus 1 T minus 2. So this is the dimension of pressure quantity. Now next is density. Density, that is rho, and what is the formula to calculate the dimensions of density? That is, we know the formula, density is equal to what? Mass upon volume. The dimension put here, the dimension of mass m1 and the dimension of volume, that is L3. So it becomes m1, this L3 becomes minus 3, L minus 3. So these are the dimensions of given physical quantities, that is velocity, pressure and density. Now we have to put all the dimensions in this equation. So equation is, so this is our equation, that is velocity is equal to root of pressure upon density. So therefore we can write here velocity is equal to root of pressure upon density. So on the left hand side velocity is there. So right here the dimension of velocity on the left side, that is for velocity L1 t minus 1 is there, is equal to under root pressure, that is force upon area. And what is the dimension of pressure? That is m1 L minus 1 t minus 2 divided by density. Density, the dimension of density is m1 L minus 3. Now we have to solve this. How we can solve this? See here, m1 get cancelled. Now remaining terms we can write root of this minus 3 becomes plus 3. So minus 1 plus 3, it is minus 2, and t minus 2 is as it is. Now taking square root, on the left side L1 t minus 1 is there, is equal to on the right side. So taking square root, here you should write taking square root, taking square root. So we get here L minus 1 t minus 1. Now concentrate on the both sides. So here on the left side L1 t minus 1, that is the dimension for velocity. So this is LHS is exactly equal to, on the right side L, see here this minus 3 becomes plus 2. So minus 1 plus this minus 3 becomes plus 3. So minus 1 plus 3, so here should be plus 2. So do not write here minus, here is plus 2, because this minus 3 becomes plus 3 and already minus 1 is there. So minus 1 plus 3, that is plus 2. So just you have to write only 2. So this is L2. So here square root of, here L1 should be there, that is L1 t minus 1, the square root of L square and t minus 2, L2 and t minus 2, the square root of this is L1 t minus 1. So LHS is exactly equal to RHS, that means both the sides which are given to us, that sides are here equal. So if both sides, that is left hand side as well as right hand side, they are equal to each other, then what is our conclusion? Then our conclusion is the given equation, whatever will the given equation to you, the given equation, which is given equation here, the given equation is here V is equal to under root pressure upon density. So the given equation is dimensionally correct. The given equation is dimensionally correct. So this is our final answer. Means this equation or this problem which we have to solve here, so that problem is dimensionally correct. Why this problem is dimensionally correct? Because after quantities and putting all the dimensions of that given quantity in that equation, we get the conclusion, that is, or we get the final answer, that is L1 t minus 1 and L1 t minus 1. Means left hand side of this equation must be equal to right hand side, and if both sides are equal to each other, then the given equation is dimensionally correct. And if left hand side and if LHS is not equal to RHS, then the given equation is not dimensionally correct. Okay. So we have to another two problems are remaining which we have to solve it. Okay. Thanks.